Hello students, today we are going to discuss group 18 of P block. Group 18, as we all know, they are commonly called as noble gases. They are also called as inert gases. Now the word noble or inert come due to their unreactive nature. All these gases do not react with any other element and therefore the name inert or noble is given to them, and all exist in gaseous state, therefore the name noble gases or inert gases is given. Now the elements of group 18 are helium, neon, argon, krypton, xenon and radon. Helium shows completion of first principal quantum shell. Neon represents the completion of second principal quantum shell. Similarly, argon, krypton, xenon and radon, they represent the completion of, that is the filling of electron is completed in third, fourth, fifth and sixth principal quantum shell. But nowadays this term gases is not used for group 18 elements because a new element called as oganesson is discovered, which has atomic number 118 and it is solid in nature. And therefore nowadays we use the term noble elements rather than noble gases. If we talk about the occurrence of these noble gases, all these noble gases except radon occur readily in the atmosphere. Not readily, but I will say in abundance. In dry air, their volume is near about 1%. 1% noble gases constitute of overall volume of the dry air. Now, radon is a radioactive element. Now, of the dry gas, argon is the major constituent, and other gases like helium, neon, they are obtained as minerals of radioactive origin. For example, pitchblende. So the minerals of certain radioactive origin, they consist of helium and neon. So overall, why do the name noble gases is given to them? Because they have their valence shell orbital completely filled, and therefore we call them as noble gases. This is a very straightforward give reason type of question. From this topic group 18, you can expect either reasoning questions or complete the equation or structure questions. As just now we have seen, the general electronic configuration of noble gas element is Ns2Np6. But remember, there is an exception of helium, which has 1s2 configuration. So remember this exception. Now since outermost orbital is completed and therefore we can say these gases are unreactive and we can attribute the noble nature towards this completely filled shells. The noble gases, they show very high ionization enthalpy, and very high ionization enthalpy is obviously attributed to their completely filled structure or completely filled orbitals, and therefore they show very high ionization enthalpy. But still ionization enthalpy decreases as we move down the group. That is, as we move from helium to radon, the ionization enthalpy decreases. Coming to atomic radii, we know noble gases are the largest in their respective period. For example, neon will have largest atomic radii in second period. Now, why do noble gases show largest atomic size? Because noble gases have weak van der Waals radii in them. And weak van der Waals radii, they are larger even than covalent radii. and therefore noble gases, they have larger atomic size. They are the largest one in their respective period. One of the expected question. Okay, but talking about the trend, atomic radii increases down the group. As we move from helium to radon, the atomic radii will increase. Noble gases show very large positive electron gain enthalpy. Now, why do they show large positive electron gain enthalpy? That means they have very less tendency to accept the electrons. We know more negative the electron gain enthalpy, more easily will be the acceptance or gaining of the electron. But in case of noble gases, electron gain enthalpy is largely positive, and the reason lies obviously in their stable configuration. So on all these topics, we can expect a give reason type of question. And whatever keywords I have written over here, these keywords must be included in your board exams. Okay, let us discuss the properties of noble gases. These are monoatomic. All the noble gases, they exist as a single atom: helium, neon, argon, krypton, xenon, etc. As well as they are colorless, odorless and tasteless gases. The noble gases show very low melting point and boiling point. Now, why do noble gases show very low melting and boiling point? Because just now we have seen in noble gases there exists only one type of atomic interaction, weak dispersion forces. And due to these weak dispersion forces, it is very easy to break the force of attraction between them, and therefore they have very low melting point and boiling point. Like helium has the lowest boiling point of 4.2 Kelvin, and it is the lowest boiling point of any known substance. So what are the chemical properties of noble gases? The noble gases, they are least reactive. And this least reactive nature is due to stable configuration as well as very high ionization enthalpy and positive electron gain enthalpy. Due to these points, noble gases are unreactive in nature, but still there are certain compounds of xenon and krypton. It was actually Neil Bartlett who observed that the first ionization enthalpy of oxygen is near about equal to first ionization enthalpy of xenon. First IP of oxygen is 1175 kilojoule mole inverse and that of xenon is 1170 kilojoule mole inverse. So when this observation was made by xenon, which was a very important observation, Neil Bartlett tried to prepare the compound of xenon and platinum hexafluoride. By doing this, he got compounds of xenon. The compounds of xenon, they are basically with either oxygen or fluorine, which are the most electronegative elements. Now, this is an important topic, that how Neil Bartlett proved that compounds of xenon can exist. A direct question can be framed over here. Coming back to the compounds of noble gases. So, xenon forms compound with oxygen or fluoride. Some rare compounds of krypton are also known, but these are very few compounds. The compounds of other noble gases such as helium, neon and argon, they are not known. Now coming to radon, it is very difficult to study radon. Why? Because it is a radioactive element. And therefore studies of radon, it becomes difficult. As we have discussed just now, xenon forms compound with either oxygen or fluorine, which are most electronegative elements. Now why xenon can form compound with fluorine? It is because of presence of 5p orbital in xenon that can be excited to 5D. And therefore xenon and fluorine compounds are known. So xenon and fluorine basically forms binary compounds like xenon difluoride, xenon tetrafluoride and xenon hexafluoride, etc. Now we can prepare these compounds by various methods. If we are taking xenon in excess, then we get xenon difluoride. If we are taking the ratio of xenon and fluorine 1:5, then we get xenon tetrafluoride. And if we take excessive ratio of fluorine, that is 1:20, then we get xenon hexafluoride. So it's a very simple trick to remember these three reactions. If the fluorine is in excess in the product, the number of fluorine will be more. Now xenon hexafluoride can be also prepared by the reaction of xenon tetrafluoride on dioxygen difluoride. The product will contain xenon hexafluoride and oxygen gas will be liberated. The next reaction is xenon fluoride react with fluoride ion acceptor to form cationic species and fluoride ion donors. For example, when xenon difluoride reacts with phosphorus pentafluoride act as fluoride ion acceptor, where one cationic species will be formed, XeF6, and PF6 minus, it will be fluoroanion. Similarly, xenon tetrafluoride reacts with antimony fluoride, where antimony fluoride will be fluoride ion acceptor to form the cationic species and fluoroanion. Now the xenon fluoride compounds, they are readily hydrolyzed even by traces of water and they act as a powerful fluorinating agent. For example, xenon difluoride is hydrolyzed to give xenon, hydrogen fluoride and oxygen. As xenon form compounds with fluorine, xenon also form compound with oxygen. We call them as xenon oxygen compounds. Xenon oxygen compounds are basically obtained by hydrolysis of xenon fluoride compounds. For example, XeF4 when hydrolyzed gives xenon and compound of oxygen and xenon XeO3 as well as hydrogen fluoride and oxygen. Also, it can give XeO3 plus 6HF if we reduce the amount of water. Now, these two reactions, they are called as complete hydrolysis. Whereas next two reactions, they are called as partial hydrolysis. Now how to identify the partial hydrolysis or complete hydrolysis? If it is a partial hydrolysis, the amount of water will be less. Generally when we are using 2H2O, we call it as partial hydrolysis, and generally when we use 3H2O, we call it as a complete hydrolysis. Okay. Xenon hexafluoride, when it is partially hydrolyzed, it gives compound like XeO4 and hydrogen fluoride. As well as it can give compound like XeO2F2 and hydrogen fluoride. In all these reactions, hydrogen fluoride is one of the common byproduct, and the product obtained by complete hydrolysis is XeO3, whereas partial hydrolysis product is either XeOF4 or XeOF2. Now these reactions are asked as complete the equation. Now let us discuss the structures of these xenon and oxygen or xenon and fluorine compounds by using VSEPR theory. The very first compound is XeF2. Now we have to use the outermost configuration of xenon. Xenon outermost shell, there are 8 electrons. Out of 8 electrons, 2 will be used in forming bond with fluorine. So out of 6, 2 electrons are used. So obviously 3 lone pair will be left out. And therefore XeF2 will be a linear structure. with sp3 dehybridization. There will be three lone pair and 2 bond pair. Moving on to the next one, XeF4. Obviously, xenon will be the central atom. Out of 8 electrons in the outermost shell of xenon, 4 will be used in forming bond with fluorine. And therefore, 2 will be left out. 2 pairs will be left out as a lone pair. As we can see in this structure, fluorine is situated at 4 different corners of a square, and therefore XeF4 will be a square planar structure where central atom will undergo sp3d2 hybridization, 4 bond pair and 2 lone pair. Moving on to the next one. The next compound is xenon hexafluoride. So 8 electrons which are available in the outermost shell of xenon. Out of these 8 electrons, 6 will be used in forming a pair or a bond with fluorine. 1 lone pair will be left out, and therefore XeF6 will show distorted octahedral structure where xenon undergoes sp3d3 hybridization, 6 bond pair and 1 lone pair. Now let us discuss certain structures of xenon compounds which has oxygen also. XeOF4. So xenon is obviously the central atom. Remember, oxygen forms the multiple bond and therefore it will form a double bond. So out of 8 electrons in xenon, 2 are already used. Now remaining 4 it will use to make bonds with 4 fluorine atoms. So out of 8 electrons which are available in outermost shell of xenon, 1, 2, 3, 4, 5, 6 are already been used, and 8th will be left out as the lone pair. And hence it will show square bipyramidal geometry. Where xenon undergoes sp3d2 hybridization. Moving to the last compound of xenon, that is xenon O3, XeO3. Now xenon again being a central element, and oxygen forms multiple bond. So these 3 oxygen will be doubly bonded with xenon. Out of 8 electrons present in the outermost shell of xenon, 6 have been already used. Only 1 lone pair will be left out. So with this geometry we can say, with this arrangement we can say XeO3 shows pyramidal geometry where xenon undergoes sp3 hybridization. So it is very easy to predict the structures of these inorganic molecules. Simply you have to remember that all the 8 electrons in the outermost shell of xenon, they have been utilized either in the bond formation or they will be left out as the lone pair. So let us discuss what are the uses of these noble gases. Some people think that since noble gases are unreactive elements and therefore they are of no use. But on the other hand, noble gases have tremendous uses. Like helium, it is used for meteorological observations. It is used in those balloons which are used for meteorological observation. Now why helium is used for these filling balloons? Because of its light nature. Secondly, it is also used as a diluent for oxygen in the diving apparatus. This we have already studied in the chapter solution. Helium is also used as a gas nuclear reactor. Liquid helium is also used as cryogenic agent, especially for the reactions which are carried out at high temperature. Neon is used in discharge tubes. You must have seen the signboards outside the shops which glows at night. These signboards make use of neon because neon is filled in fluorescent bulbs, especially for advertisement purposes. Also neon is used in botanical garden, greenhouses, And argon. Argon is used for filling electrical bulbs. This we are studying from our childhood, that electric bulbs are filled with inert gases like argon. As well as argon is used to provide an inert atmosphere wherever high temperature is required. So with this we have completed group 18 elements. We have discussed their physical properties, we have discussed their various trends, we have discussed their chemical properties, as well as we have learned how to draw the structures by using VSEPR theory. So based on today's video, here are certain self-to-do questions. Solve it by watching this video. Thanks for watching. That's all for the day. Have a nice day.